So everyone, this is part 2 of how to answer exam questions with mineral identification in. Hopefully you've had some time to construct your answer to the first example using the information about calcite and quartz and how resistant or susceptible they are to physical and chemical weathering. We're now going to have a look at another example that appeared on your recent mock. So this example is talking about transport of grains to make sedimentary rocks, and it has two different sediments that become rocks of quartzite and feldspar-rich sandstone. So first of all, what we need to think about is what do we know about transport, and then we need to think about what do we know about the two named sandstone minerals in the question. Well, what do we know about transport? Weaker minerals tend to be destroyed. It's told you that here in the question. The second part is thinking about why then does quartz end up in high energy currents forming quartz-rich or quartzites rather than feldspar being transported far distances over high energy currents to produce feldspar-rich sandstones. So quartz survives, feldspar doesn't. What do we know about these two minerals? So that's where we're going to refer to the mineral data sheet to find out. So we're thinking about transporting both of these minerals over a long distance in high energy. Here they are. So I've got the two different types of feldspars and also quartz. And we have to think about what properties are going to cause a mineral to break down or be weak when it's being transported over a long distance in high energy. So again, we're going to ignore things like the luster, the streak, the colour, perhaps even the density, because they're very much the same. But we are interested in the hardness, and we're also interested in the cleavage as well, because they're really where transport is going to actually start to break apart these particular minerals. Now, first of all, most of you seem to pick up the fact that they have very similar hardnesses. So the hardness of feldspars is around about 6, hardness of quartz is 7. They are quite similar, but 7 is actually a whole, which is logarithmic scale, so it's a whole 10 times harder than hardness of 6. So quartz is harder to start off with. The second thing that we can see is that quartz has no cleavage planes within it. It does breaks like glass, but it doesn't have any planes of weaknesses, whereas feldspar has 2 good planes of weakness in terms of cleavage at 90 degrees. And so as you're transporting these minerals, they're going to start to break apart to have those cleavages. So we know that weaker minerals tend to be destroyed, and we now know that quartz has a hardness of 7 but no cleavage. Feldspar has a hardness of 6, but it has 2 good cleavage planes at 90 degrees. So what makes feldspar less resistant must be the cleavage plane, and also, although they're reasonably similar hardness, it's 10 times less hard than quartz. I'm going to ask you to pause so that you can answer the question in your own words. Pause now. Okay, so I'm hoping that you've constructed an answer to example 2. I'm now going to give you the opportunity to try 2 more examples from recent exam papers. So here is example 1. You're going to need a textbook, you're going to need a mineral data sheet, and this question is worth one mark, the second question is worth 3 marks, but I'll go through that in a moment. Press pause now. Okay, so you've answered question 1, example 1. I'm going to flick over to example 2. Here it is. This one's a little bit more complicated. It's worth 3 marks, and it's about sedimentary rocks. And you're going to answer it now, so press pause. Okay, so you've had the opportunity to answer 2 more questions, and I will take a look at those when we return after our break. I hope you enjoyed going through this, and you can watch it and rewatch it anytime you like. Okay, goodbye!